Question 6 asks us to graph the solution set for the system of linear inequalities that we wrote in question 5 and label all points of intersection of the boundary lines. So we go back and look at the linear inequalities that we wrote in question 5. We have x is greater than or equal to 0, y is greater than or equal to 0, x plus 2y is less than or equal to 72, and x plus y is less than or equal to 40. So the way that we graph these is we pretend like they're lines, and then we just figure out which side we graph. So the line x equals 0 is the same as the y-axis. So we're going to draw a line here on the y-axis. And the line y equals 0 is the same as the x-axis. So we'll draw that line. And then these next couple of lines, we could either graph them using standard form, and I think this one would be easier using standard form, or we could graph them using y-intercept, and I think this one would be easier using y-intercept. So to graph using standard form, we plug in 0 for x and y to get 2 points, and then we draw a line through those 2 points. So if I let x equals 0, then 0 plus 2y equals 72. Divide both sides by 2. That means y equals 36. So I'm gonna make these go by 10 like this. 10, 20. Oh, that's 20. 10, 20. 30, 40, down here 10, 20, 30, 40, 50, 60, 70, 80. Okay, so I have a point at 0, 36, which is right about here, and I should draw this in black. So there's 0, 36. We'll label that here, 0, 36. Then I'm going to let my y equal 0, so I'd say x plus 2 times 0 equals 72, which means x has to be 72. So I put another point here at 0, 72. And now I can draw a straight line through those. So this is 72, 0. Straight line. Make that, there we go. So that's the line x plus 2y is less than or equal to 72. And because it's less than or equal to, we'd be shading below the line. Okay, so this means we're going to shade below this line. Now we want to graph x plus y is less than or equal to 40. This one I think is easier to use y equals mx plus b, because all we have to do is move x to the other side. So we would subtract x from both sides. So here's x plus y less than or equal to 40. If we subtract x, we get y is less than or equal to negative x plus 40, which means I'm going to have a point at 40 on the y-axis and another point at 40 on the x-axis. So let's draw those. So I have here, I start at the point 0, 40, and then I'm going to go down 1 over 1, which means I'll end up at the point 40, 0. And we'll draw a straight line here. And this one is also going to be shading below the line, which means the area that I'm going to have shaded is below both lines, which means, let's make sure that this is, there we go, it's going to be shaded below both lines. Okay. So that's the area that's shaded. So now I've graphed the solution set. Now I just have to label all of the points of intersection. So I'm looking for 4 points. I'm looking for this point, this point, this point, and this point. Okay. I already know the first point, that's 0, 36. I already know the fourth point, that's 0, 0. I already know the third point, that's 40, 0. The only one that we need to figure out is this one right here. And that's the most important one because that's the answer to number 7. So it looks complicated, but we just have to solve the system of linear inequalities to figure out what that point is. So if we say x plus 2y equals 72 and x plus y equals 40, we just have to figure out what point is on both of those lines. So we're going to subtract this bottom equation from the top equation, and the x's cancel out. 2y minus y is y, and then 72 minus 40 is 32, so that's our y value. Plug that into this first equation, and we get x plus 32 equals 40. Subtract 32, and x equals 8. Boom, now we just found 832 as the solution of that system. So that is the second point that we were missing right here, 832. So now we found all the points of intersection, and we graphed and labeled it. So here we have 0, 0. We already labeled 0, 36. Here's 40, 0, and then here is 832.